Hi friends, here's a video on adding and subtracting integers. As a quick reminder, when we talk about integers, we are referring to the whole numbers, that would be 0, 1, 2, 3, 4, 5, 6, and so on, as well as the opposites of those numbers, 0, -1, -2, -3, and so on. We can use a number line to graph integers. Here's an example number line. And when we want to represent a number, we will plot a point at that location on the number line. Notice that our positive numbers are to the right of 0 on the number line, and our negative numbers are to the left of 0 on the number line. As we move to the right on the number line, we are increasing. Numbers get larger. As we move to the left on the number line, our numbers decrease and they get smaller. So any number that's to the left of another number on the number line, that number on the left would be a smaller number. The number on the right would be the larger number. When we talk about integers, we refer to the positives and the negatives as being opposites. So +3 and -3 are opposites. Opposites are numbers that are the same distance from 0 on the number line, but they are on opposite sides of 0. So as I said, 3 and -3, 8 and -8, 12 and -12, those are all pairs of opposites, and so on. And 0 is right in the middle. You could think of 0 as like its own opposite. So there's no positive or negative 0. However way it shakes out, a positive 0 or negative 0 is the same, just 0. But aside from 0, we have whole numbers 1, 2, 3 increasing, and then we have the opposites, -1, -2, -3, and so on decreasing. And that distance from 0 on a number line is what we call the absolute value of the number. And the absolute value is a distance from 0, so we refer to that as a positive amount. So 3 and -3 have the same absolute value, 3. They are both 3 units away from 0 on the number line. We focus a lot on adding integers because we do it all over the place in mathematics. So we'll spend a little bit of time trying to create our own sort of go-to mental ideas about how we can conceptualize the addition of integers. So we'll talk about ways that we can see it on a number line. We'll also talk about it as a money example where positive numbers would be money that we get paid. Negative numbers would represent money that we have to pay out, like bills, paychecks and bills. Positive numbers paid, negative numbers bills, stuff that we owe. We will also touch on an idea that's pretty similar to the money idea. You could think of it as like piles and wholes, or two kinds of numbers that when put together it equals 0. Like you have a hole and then you have a pile. The pile would fill up the hole and you are left with 0. So we'll talk about those three concepts, and hopefully you'll begin to identify a connection to each of those and possibly a preference for one way that really feels comfortable to you when it comes to adding integers confidently and correctly. Let's take for our first example 6 plus -4. And now let's look at doing this addition on the number line. We will first go to or locate on the number line that first number 6. So let's go to 6 on the number line and let's plot that point. There's +6. Now when we add a positive number, we would increase and go to the right. But when we add a negative number, we are decreasing and going to the left, or the opposite direction. So 6 plus +4, let's do that just temporarily. A +4, we would move 4 units to the right and say 6 plus 4 equals 10. But in this example, we are adding the opposite of +4, -4. So let's move to the left on the number line by 4 units. And from +6, we go to the left down to 5, 4, 3, and then we land on 2 after we have added -4, moved 4 units to the left on the number line. That means that 6 plus -4 equals +2. Using a money example, +6 would be $6 that we are going to be getting paid, plus 6. But the -4 will be $4 that we owe, that we're going to have to pay out. So can you conceptualize what would be the result of those two transactions? You gain $6 from that positive 6, but then you're going to have to pay out 4. And going to a money example can be helpful for some people. The proof is if it helps us get to a result of positive 2, that after those two transactions, getting $6, but then paying back 4 of them, that we are left with some money still, so we have a positive result, but we're left with just the $2, so our result is positive 2. We can also see that idea with like the piles and holes kind of example, so let's bring that into the mix. This approach is a little bit different from the money example because we don't automatically look at that negative 4 as $4 that we're taking away from what we just got with that $6. We're going to lay out 6 of a positive unit, and then we will take 4 of a negative unit. And if you saw my collection of green squares and red squares, you might expect that the 4, or the negative 4, will be represented with 4 red squares. So positive 6, 6 green, negative 4, 4 red. Keep in mind that we are still completely talking about addition. We have a positive 6, a negative 4. We are adding them together. So all these ideas are ideas that we apply when we're thinking about adding together integers. A critical idea that comes into play with this concept is the idea of a zero sum, is one term for it. And that's thinking about what is the result of putting together one green with one red, a positive 1 with a negative 1. They are opposites, so they add up would equal 0. That's something that all pairs of opposites do. When we add them together, it equals 0. Some people like to use that word, they cancel out. I'm not such a fan of that word when it comes to math because we have better adjectives for what's actually happening or better words to describe the actions that are happening, the verbs. So I don't choose to go with cancel. We're going to say in this case, they sum to 0 or they zero out. Probably sum to 0 is the most accurate of what we're talking about. So we'll put together pairs of greens and reds, positives with negatives. And we'll understand that a pair of a green with a red equals 0. It's a zero sum pair. They zero out, they add up to equal 0. What we're interested in is what's left behind after we have paired up a positive with a negative and know that those things just wipe each other out. They add up to equal 0. When we start with positive 6 and then bring in negative 4, we will be able to see 4 zero-sum pairs. 4 pairs of a positive 1 with negative 1 that add up to equal 0. But then let's see what is left over from those two numbers that we were putting together, positive 6 and negative 4. We see that there are 2 positives left. So that would be another way for us to see that the sum of positive 6 and negative 4 is positive 2. If you're thinking about what do the rules say about adding integers, I'm very reluctant to bring up the rules. I think you articulating the rules to yourself is a great thing to do once we've become a little bit more comfortable with the process of adding together positives and negatives and applying some of these concepts that I think are a little bit more concrete, or we can maybe conceptualize them a little better than just rules. So I'm not saying the rules aren't helpful. The rules can be a little bit confusing. I don't think they're a great place to start. I think the rules could be a good place to kind of conclude and wrap up and kind of summarize what we understand about adding integers. So we'll hold off on the rules and we will continue to focus on number line, money example, and these zero-sum pairs like piles and holes, positive charge and negative charge, or any other kind of example you could think of two opposites being put together that when together it is a total 0 out. Now let's take this next example, negative 7 plus 3. And let's go first to the number line. We start at negative 7, and now we are adding a positive 3. So we are moving to the right on the number line. From negative 7, going to the right 1, 2, 3 units, and we land on negative 4. So there's our sum. Negative 7 plus 3 equals negative 4. Let's try it with the money example. negative 7. So you start with 0 and now you are in the hole already. You owe $7. You have to pay out $7. But before you go fishing into your wallet or purse or whatever you have to hold money, we now will add a positive 3. So you'll actually be getting paid $3. So what is the result of those two transactions? You will owe $7, but you're going to get $3 back. So from that, can we begin to conceptualize that actual physical transaction? I'll need to pay out 7, but I'm going to get some credit for 3. That leaves me still owing some money. Because I had to owe $7, I'm only getting credit for 3. So that could be a way for us to see that we still owe $4. So our answer is negative 4. Now let's go to the zero sum visual aids and put that together. I've brought out 7 red units to represent the negative 7, and now adding positive 3, so let's bring in 3 green units. Now when we add, we are looking for zero-sum pairs that we can get out of the picture and see what's left behind. They're actually grouped together kind of nicely, so we can see right here 3 zero-sum pairs. A pair of a red with a green equals 0, and we've got that 3 times. And let's see what's left over. 4 red units, which represent negative, so there's our result, negative 4. Let's do a quick comparison with the previous example, which was 6 plus negative 4 equals positive 2. A quick note about the parentheses, they are used just to keep things looking clear. So we don't usually see a plus and a minus sign right next to each other. If we want to indicate 6 plus negative 4, that's a time when we would put parentheses around that negative 4. So it's looking more clear that it's a positive 6 and a negative 4, and the operation between them is addition. In this more recent example, negative 7 plus 3 equals negative 4, we don't have the negative number in parentheses because we don't have a plus and a minus symbol side by side. It would not be incorrect at all to put parentheses around that negative number. That does make things look more clear to me, and if that's our goal, then we should go ahead and do that. But we would not very frequently see that happen. So just a heads up about the parentheses. We know parentheses with numbers sometimes indicate multiply. We'll get to what that looks like in a bit. For now, keep in mind that everything we're thinking about right now is about addition of integers. Reflecting a little more about these last two examples, when we had 6 plus negative 4 equals positive 2, thinking not about the plus and the minus parts, just thinking about like the magnitude, the size of the numbers. There was a positive 6, but the negative number was just a 4. So the positive number had the bigger magnitude, like bigger strength from a positive side. There was a negative 4, but it's not as large as the 6. Maybe what I really should be talking about is absolute value. Thinking about the absolute values of those numbers, it's the positive number that has the bigger absolute value, and that is the reason that our answer was positive. Think back to the number line. We started with a positive 6, and then the negative 4 meant we had to be moving to the left, but it wasn't enough to push us all the way past 0 into the negatives. It brought us to the left a little bit, but we stayed on the positive side because the 6 had the bigger absolute value. Or thinking about the money example, positive 6 compared to negative 4, we ended up with more money coming to us. So in the end of all that, with the addition, we should have money that we have for the leftover, that positive 2. Looking at negative 7 plus 3, now it's the negative number that has the bigger absolute value. And that does mean that our answer would be negative. Whether it's the number line, so we start at negative 7, plus 3 moved us a little bit towards the positives, but not far enough. It didn't move us close enough to 0 and beyond. We would have needed to be adding something that's got an absolute value that's more than 7, or putting us more than 7 units in the positive direction. Or with the money example, a -7, we owe $7. So in order to end up on the positive side of things, we would need to be adding in a positive number that's more than 7. We were only adding in 3. So we would expect that our answer would be negative. We're ending on the withdraw or the debit side of things, not the credit. We don't get money, we owe money, because looking at our two integers, the negative number had the bigger absolute value. So the negative number in the addition was sort of more powerful than that positive 3. So that's another thing that we can observe when we add integers. Looking at the absolute value of those two numbers, whichever number has the bigger absolute value, the sign of that number tells us our answer. You have a bigger absolute value in the positive, your answer will be positive. That was our first example. Your absolute value of the negative number is bigger, that means your answer will be negative. Let's tackle two more examples real quick. Let's do -3 plus -9. And then we haven't done just two positives, so let's bring that in just so we can get closure. We had adding a positive with a negative, two different versions where your answer could be positive or your answer could be negative. Here, let's see how it plays out. On a number line, let's start with -3 plus -9. We would first go to -3 on the number line, then adding -9. Adding a negative, we're going farther left on the number line by 9 units. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, and we land on -12. Now think of a money example. -3, so we owe $3. Now adding in a -9, so that's another bill. We owed 3, now we owe 9 more, so I'm just owing more dollars. 3 owed, 9 owed, now there's a total of $12 that I owe, and that's our answer, -12. We owe $12. How does it look with our visual aids? We start with -3, and now we're going to add to our -3, -9. So 9 more reds coming into the picture. Here's where we would look for zero-sum pairs, a red with a green, a positive with a negative, but we have not even brought any positives into this picture. It's just all negatives. So we had -3, we brought in 9 more negatives, so we see our result is -12. Let's go to +4 and +5 added together. On a number line, we start at +4, add 5, so we'll be going 5 units to the right to make this number increase. +1, 2, 3, 4, 5, and we land on +9. Good old-fashioned adding of positive numbers, like we used to do. Well, we still do, but now we're just bringing negatives into the picture, and every once in a while we end up with just positives that we're putting together. 4 plus 5, 9. Money example. We're going to get paid $4, and then we're going to get paid $5. Nothing about owing money is even in this problem, just paid. I get paid 4, I get paid 5. After all that happens, I've been paid $9. So my answer is +9. And to complete the picture, let's look at the visual aids. +4, so let's grab 4 green units, and that will add to that 5 green units for a +5. No negative numbers at all in this addition, so +4 with +5 shows us a total of +9, just what we would expect. So if we have two negatives put together, we're just going further and further into the negative direction, like you're just getting bills stacked one on top of another. And when they're all positives, you're just continuing to go into that right direction on the number line, positive direction. Just like the money's coming in, not having to pay anything out, 4 and 5, 9. If they're the opposites, it works the same way, but just negative direction. 3, bill for $3, bill for $9, total bill for $12. So let's look at a few more examples that get a little bit more in-depth, and we will apply some of those addition properties, commutative property, associative property, and we will see how those properties can help us handle some larger problems of adding integers. And here's this example for us to try. -5 plus 8 plus -2 plus 5 plus negative 6 plus 2. Notice that we have only additions in this problem. Looks like we've got 6 numbers, but the only operation taking place is addition. When we recognize that, we can use a commutative property or an associative property, generally an idea that we can put the order of these numbers in the addition any way that we like and always get the same result. So let's examine maybe 3 strategies. There could be others. Let's look at 3. So one strategy is that we just march left to right. And as we encounter pairs of numbers, we just add them up using those concepts that we've been developing. We either look at a number line, or we think of a money example, or some sort of visual aid to help us find zero sum pairs. But overall, with a problem like this, we just go left to right, pair of numbers, then we bring in the next, and then the next, and so on. So let's do that, starting with negative 5 plus 8. So on a number line, going from negative 5 and then adding 8. 3, 4, 5, 6, 7, 8. Looks like that would put us at positive 3. Let's double check that with the money example. Negative 5, so we owe $5, but positive 8, so we're getting paid $8. What's the result of those 2 transactions? Or think of it with the visual aids. Negative 5, I'm not going to copy and paste them over, I'm just going to circle negative 5, so 5 reds. 8 greens, so 8 greens for the positive 8. And let's look at our zero-sum pairs. Those all zero out, a positive 1 with a negative 1. And we are left with positive 3. Pretty nice. Okay, so negative 5 plus 8 equaled negative 3. Now let's just keep on marching. Next we have to add in a negative 2. Again, number line, negative 3, but plus negative 2, so we're continuing to move to the left on this number line. Negative 3 plus negative 2 would be negative 5. Thinking about a money example, we owe $3, now we owe 2 more, so we owe a total of negative 5. Or our visual aids, negative 3 could be 3 red units, plus negative 2, 2 more red units, and we see a total of 5 red units for the negative 5. So at least we're consistently getting that result. And again, we want to begin to identify what are some of the ideas that are just becoming more comfortable, feeling a little more natural for us. We want to be consistently accurate and feel some level of confidence with what we're doing. So negative 5. Now let's bring in the next one, which is plus 5. We should recognize opposites. Negative 5 with positive 5 equals 0. It's like you owe 5, but you're going to get paid 5. You're left with nothing. Nothing lost, nothing gained. Or with our visual aids, negative 5, positive 5. Those would be 5 zero-sum pairs. So any way you slice it, we would be left with 0 after adding in that positive 5. My work's getting a little messy here, so apologize for that. If we're working through a problem like this as part of a bigger problem or something that we want other people to look at, we may want to try to be a little bit more clear. We'll develop that as we go. For now, we're focusing on these concepts, seeing the adding integers. So 0, bring in the next one, plus negative 6. Well, hopefully we remember a property that anything plus 0 is that same number. We should still be left with negative 6, but all of our other ideas still work. Negative 6 on a number line plus 0, so we go 0 units left or right, doesn't matter. 0 units is we're still at negative 6. Money example, we have nothing and now we bring in $6 that we owe. Okay, so I owe $6. I'm at negative 6. Visual aids, we're starting with 0, so no reds, no greens. And now we are adding in 6 reds. So we're going from nothing to owing $6 or having 6 negative units. So we are at negative 6. Finally, let's bring in this plus 2, the very last number that we must add in. Think of a money example. I owe 6, but I'm going to get paid back, but only paid back 2. So I'm still in the hole. I still have a negative result, owing $4. On a number line from -6, adding a positive 2, we would be moving to the right to get to -4. Visual aid, we would have 6 red units, adding in a positive 2 for those 2 green units. We'll have some zero sums, and we'll have -4 left over. So that's one approach for a lengthy kind of problem, which is definitely applicable to what we'll be doing and what you will be doing in the future. It's, sometimes we just add together a couple of integers, but sometimes we're looking at a problem where we have many of them to add together. So this is not just making complicated problems, it's actually making some realistic problems. So let's finish clearing this out. Oh, too far. And talk about a second strategy where we can begin to take use of or make use of those properties of addition. So we can do the addition in any order. Some people like to group together all the numbers that have the same sign, because that's more like the kind of addition that we're used to. I don't have to think about zero-sum pairs and mixing up money that I get versus money that I owe. If they're all negatives, they just get combined and the answer is still negative. Like you owe 5, you owe 2, okay, so now I owe 5 plus 2 is 7. And then another -6, so I owe 7, I'm gonna owe 6 more. So from those 3 negatives, I have a total of a -13. If we're thinking number line, I'm just going left, and then farther left, and then farther left, even off the number line all the way out to -13. Or with visual aids, they're all red units. 5 reds, 2 reds, 6 reds, gives us a total of 13 reds. So we're taking advantage of, we can add in any order, and we're going to grab all the negatives. And then with that on hold, let's put together all the positives. +8 with a +5. So you could think with the money example, I'm getting paid 8, I'm getting paid 5 more, so now I'm up to 13. Getting paid another 2, I'm up to 15. So a +15. On a number line, that would be we're going to 8, we're going to the right, we're continuing to go to the right when all we do is add in more positives. With our visual aids, it's greens. 8 greens, 5 more greens, 2 more greens. We have a total of 15 greens. So maybe we begin to see the advantage of splitting up, doing a little bit of a different order to focus just on the negatives and just on the positives. And then just one time we'll be putting together one positive with one negative. -13, so like I owe 13, but a +15, I'm getting paid 15. As a result of those 2 transactions, I would be left with money, so a positive answer, +2. And again, we can go back to the number line, we can go to the zero-sum pairs to see that a -13 with a +15 would equal +2. So that's a second approach, taking advantage of add the numbers in any order that we like. A third approach is one that we might use depending on the numbers in the problem. It would be based on trying to find some zero-sum pairs, just picking and choosing from the starting numbers. So if we see there's a -5 and a +5, we know those numbers add up to equal 0. I'm just putting a little arrow 0, like those 2 together, they zero out. They're opposites, -5, +5, wiped out. I see another pair. Here's a -2 with a +2, also 0 out. So looking at pairs, you can pull them in any order. That's helped clean this problem up a lot. We're left with a +8 plus -6. So let's go to one of our 3 concepts. A number line, +8 but then adding a -6. So we'll be moving to the left. 1, 2, 3, 4, 5, 6. It's good that we're getting the same answer each time. It should always be +2, any way that we slice it. So number line, we see the +2. Money example, I get paid 8, but then I have to pay back 6. Well, I still have $2 in my possession. There's the +2. Or thinking about the visual aids, +8 would be that many green units. -6 would be this many red units. Several zero-sum pairs with 2 positives left over for that answer +2. So that is an overview of adding integers. We make such a big deal about this because only when it's all adding can we do things in different orders to our benefit. If we had some subtracts in there, we could be going off path if we just pull things out of order. But the bigger reason is that when we start getting to subtracting integers, our approach will be to take any subtraction and change it to an addition of the opposite. We will consistently make that small move with all of our subtractions, and that creates an addition problem. So all the stuff that we think about right here, that we spend a lot of attention and effort thinking about and trying to develop some good consistent thoughts for how to be accurate, efficient, comfortable with this, we'll continue to do it. When we have a subtract, let's say, how can I change this back to an addition and go to my comfortable place of putting together integers through addition? So we'll take a look at that next.